Okay, hello, welcome to my channel. In this video, we want to find the real values, all right, for x that will satisfy this equation. So we have a quadratic expression here raised to another quadratic at the top, and then the right hand side is just equal to 1. And in fact, the right hand side has made everything a lot easier for us, because if the result gives us 1, we have something like this. Let me say we have an expression, we call it a, raised to another expression, we call it b, all right? And then the result, which is the right hand side, is just 1. That tells us that a is 1, a can be 1. Okay, that tells us that a can be 1, or the power, which is b, can be 0. You notice that if you raise this to power 0, the result will be 1, right? And also, if you have 1 as a base, the power can be any real number, the result will still give us 1. And remember, we want to look at this over the real numbers. Okay, so let's keeping that in mind, we are going to have that this base here can be 1, or the power there will be 0. So the case 1, let me put it here. Case 1 tells us that the base, which is x squared minus 5x plus 5, can be 1, right? And in fact, let's just solve that as immediately. And the case 2 tells us that the power, which is x squared minus x plus 2, should be 0, right? So in fact, from the first case, this is 1 here. We can subtract 1 from both sides. We are going to have that x squared minus 5x plus 4 is in fact 0, right? Okay, that's very nice. Now let's see how we can solve or find the values of x from this equation. So you see, we need two factors. When we multiply it to give us 4, when we add, we will get negative 5, just to get the solutions. So if we choose negative 4 and negative 1, you notice that the coefficient here is just 1, and then we work on that a little bit. We're going to notice that x could be 4 or x could be 1. In fact, these two solutions here, these two roots, okay, will satisfy this equation, given that when x is 4, this base will be 1, and when x is 1, this base still remains 1. We raise 1 to some power, the result in fact is going to be 1. That makes sense, right? So let's look at the second case, where the power is equal to 0. So you notice this is the power here, which I've written down here, and we are equating it to 0. Well, this right here unfortunately has no real solutions, right? The discriminant here is less than 0, because the b in this case is negative 1. If we square that, we have 1, and then we say minus 4 times a times c. A times c. In fact, the discriminant is going to be 0, negative less than 0. That means this right here has no real solution. So let me put it here. The case 2 has no real solutions. That is to say, no real values of x. Right? Values of x. So what does that tell us? That tells us that this right here will not give us real solutions. So we want to find real solutions for this equation. So in fact, we are going to ignore the second case. So does it mean that these are the only two values of x? Well, no. We have, in fact, other values of x that will satisfy this. Well, how can we get that? How could it be possible that this raised to some power will be 1 if it's not only these two cases that we should consider? Well, there's one more case. There's another case that we can consider, and that will be based on integers. In particular, when we talk about even numbers and odd numbers. Now let's look at this. You notice that since this is equal to 1, if we have minus 1 and we raise it to an even number as a power, right, the result will remain positive, because this right here is an even power. So the only thing we need to know is, does this power remain even for all values of x, or maybe for all integer values of x? If that is the case, that means that this base here will just be negative 1. We won't have an issue, because if we raise negative 1 to an even power, we will still have 1 on the right hand side. So the only thing we need to do right now is to investigate the power to see if it will remain even for all whole integer values of x. Okay, so let's see. When x is odd, right? So let's say if x is odd, right? We want to see what happens. So you see, this is x squared. Well, when you raise a square, when you raise an odd number to power 2, the result remains odd, right? So if x is odd, x squared to power 2, which is an odd number to power 2, remain odd, minus an odd number, because x is just odd. So if you have an odd number minus an odd number, well, when you subtract an odd number from an odd number, the result remains even. Alright? And then we now add, this here gives us even in this case. We now add it to an even number. In fact, we remain even for x when x is odd. So in fact, the quadratic term, let me just put it here, q, which is the quadratic at the top, right, is even when x is odd. That is very nice. Now let's look at a case when x is even. Okay, so I'll say if x is even, we also want to see if the power will still remain even. If that is the case, then we can just call this base -1 and you'll be okay with that. So let's see, if this is even, when you raise an even number to power 2, okay, the result stays even. Say minus an even number. The difference between two even numbers remains an even number, right? And then we add an even number to this result. We still remain even for odd and even number and values of x. So that means q is still even, where q remains the quadratic at the top. So that what that tells us is that for all integer values of x, okay, whether even or odd, the quadratic at the top remains even. That means if we put this as -1, we are raising it to an even power, right? So let me just say, from that tells us, this right here implies that we can call this x squared, we can call that, which is x squared minus 5x plus 5, to be in fact -1, because we can raise it to an even power. The result will evaluate this -1 and to become just 1, which is the right hand side. So we are on the right track. Very nice. So let's see what we got. Well, we can add 1 to both sides. We're going to have, this will tell us that x squared minus 5x plus 6 is equal to 0. So we need to figure out what the values of x are. And in fact, should keep in mind this was just 1. We were able to just conclude the answers, right? So let me see what we can do here, given that the coefficient of x squared is just 1. Well, we seek two numbers. When we multiply, it gives us 6, and then when we add, we get -5. Well, if we multiply -2 and -3, we will get +6. And if we add them together, we are going to get +5, which tells us that in fact x equals to 3, or x being 2 is also another possible solutions for that. So we have 4 different values for x. We have x could be 4, 1, 3, or 2. In fact, these are all the real values of x, right? And if you like, you can go ahead and investigate the complex world to see the complex possible values of x that will satisfy this equation. But for now, that's a nice place, and thanks for watching, and please share this video, subscribe to my channel, and see you in our next video.